We're going to start this video with a general introduction to statistical inference. And then we're going to see how to select a simple random sample. And we also are going to talk a little bit about the point estimation, and we're going to see how to compute point estimates for population mean, population standard deviation, and population proportion. For selecting a simple random sample and point estimate, we're going to use data file EAI. When we are interested to know something about a population, the first way that comes to mind, the first thing that we can do is to run a census. Census would be collecting data from every single member of the population. So that's basically the way that we should go if we need to know the exact value of the parameter that we're looking from a population. But most of the time, census is not the best way. And sometimes it's not actually possible. Censuses can be very expensive, depending on the population, depending on the size of the population, depending on the type of data that you need to collect. It can really take too much time. It can be very expensive. You just need to, usually time and money, they just go together. When something becomes time consuming, it also becomes like energy consuming and money consuming as well. Imagine you want to know the average wealth of a US citizen. One way would be just to go ahead and run a survey and ask every single citizen of the United States, ask everyone. That takes a lot of energy, that takes a lot of time to collect all these information from all members of the population. Collecting data from all the members of the population, running the census can be misleading also. This is because usually censuses are run because of the fact that they're expensive, because of the fact that they're time consuming. Usually they run every few years. For example, US census is run every 10 years. And when you want to go back to a piece of information that has been collected, let's say 5 years ago, maybe last year in 2019, if somebody wanted to get something from census, they had to go back to data collected at 2010. So you see that data can be outdated. When we're talking about these rapid changing markets, the data can be really misleading. The data about the population, data about education, data about wealth, basically the spread of the wealth and income throughout the United States. The census can also be unnecessary. Most of the time, you don't have to spend the time and money for running the census, simply because you don't need to know the exact value of population parameters. Just an approximation would do. So for example, if you need to know the proportion of the people in your area that are willing to buy your product, as long as you know, for example, if the very, very exact value is 0.45%, like 45% of the people are going to be willing to buy your product, if that is the exact value, and this is the value that if you run a survey, if you run a census, you're going to get to that. As long as you, for running your product for planning purposes, as long as you have a value between, let's say, 40% and 50%, it's really not going to change the accuracy of the value, the proportion of people who are going to buy your product is not going to change your planning a lot. So you don't really need to know the exact value for planning for management purposes, right? As long as you have a good, accurate enough approximation, you're good to go. You can start planning, you can start controlling and executing your plan, basically. Sometimes censuses are impractical, depending on the type of data, depending on the basically variable that you're looking for. That sometimes it's impossible to run a census. For example, if you need to get the resistance of a material against heat or against physical pressure, what you need to do, you need to put that material against physical pressure up to a point where the material actually is destroyed. So you need to keep pressuring the material until it becomes destroyed. So this is a case of destructive test. And in these cases, actually, census mean, you have to put all your production in that experiment. This is something that you don't want to do that. Indeed, you want to reduce the number of cases that you put to that destructive test, right? So this is a case where census would be impractical. All right, so what do we do if in cases where census is expensive, too time consuming, misleading, unnecessary, or impractical? What we do, we try to infer actually the parameters, infer the critical values from the population using a sample data. So if we're looking to know, let's say, the population mean or a population average of income, for example, or average GPA of students at Cal State system, what we can do, we can take a sample and then using that sample, we infer, make some conclusion about the population parameters. So that's all that we want to do in a statistical inference. Gaining some insight, gaining some information, making some conjecture about the population using a smaller sample, right? Which takes less time, which takes less money. It's possible, and it's it's all those negative aspects, all those disadvantages that we just talked about. We can resolve all of those using a small sample, right? When we have sample, the sampling error, definitely the answer that we get from the sample is not going to be, there's no guarantee that what we get is 100% accurate. And we always have, because the sample that we take is random, we always will be dealing with some sort of, some amount of sampling error. There is also another concept here, sampled population. Usually we have two concepts here. We have a target population and we have a sampled population. The target population is the complete list of all the members of the population, all the, I'm just going to explain this with an example. Let's say you are running a survey you're actually interested in knowing the proportion of people who are going to buy a certain type of sandwich at a restaurant, for example, at San Marcos. Any person in the United States and in the world actually can happen to be a customer, a potential customer in the next year. Any person in the, in Europe may have a travel, may have a trip to US, may have a trip to San Marcos next year and be your guest, be one of the consumer of your sandwich, right? So that can be your, that person, even though we know the chance is almost zero, any person in New York can be, in your target population, right? But when you want to take a sample, it's going to be too much, too large, the target population. And whenever somebody's a part of your target population, but the chance is very, very tiny, what you do, you take a sample population, which is usually easier to get. Sample population is an approximation of the target population, something that is easier to get. What you do, instead of just going through the whole list of US citizens, you go with the residents of San Marcos. So you just go with the local people. There might be people that never try your sandwich, and you still have to include them in your sample population, but that's okay. That's easier to actually have a like a local sample here in this case. And the objective, your objective when you're taking a sample from a population, your objective should be, the first objective should be to bring your sample population as close as possible to your target population. That's one thing that we should do. Frame is, once you select your sample population, frame would be the list of all the members that you're going to take your sample out of that list. So that's basically a complete list of all the members, all the candidates, among which you're going to pick some of them as your sample for your study, for answering your research question. All right. So our job in a statistical inference would be taking a sample, right? And then depending on the type of population, we may have a finite population when you know exactly who are going to be a member of the population. For example, this can be the finite population, the list of all the students in Cal State San Marcos. So there is a finite population in this case, right? Or population can be infinite on the other hand. Infinite population, similar to the example that we just brought up, all the people who are gonna buy a sandwich from a restaurant at San Marcos. So the population here is infinite. You don't know who's gonna be actually a candidate, a potential customer in a period of time, for example, in the next year, right? So that we have finite population when you can have a finite list of all the members of the population, right? And then depending on the type of population, finite versus infinite, we have several different ways that we can take a sample, hopefully a random sample, right? So we have another definition here, parameter, which I already used this term. Parameter is a measurable factor that defines a characteristic of a population, process, or system. Here we're dealing with the term population mostly. I'm using population term a lot instead of system, instead of the other terms that might be relevant in business, all right? So a measurable factor, all those measures that we talked about in descriptive statistic, when we want to describe the location, when we want to describe the variability in a distribution, all those factors, for example, mean, median, mode, variance, range, standard deviation, all of them, they're all quantifiable, they're all measurable factors, and they're actually characterizing one aspect of the whole population, the distribution of a distribution of members of a population, right? So they're called parameter. Their value is always fixed. So there is a specific value, very, very exact value for each one of those parameters, because population is fixed. I mean, I know that population can be finite or infinite, but still population in its nature, in its heart, is a fixed concept, right? And then since population is fixed, the parameters are also fixed exact values, but we do not know them unless we run a census, right? Which we are not going to do. We're going to use statistical inference, all right? So sampling from a finite population, I'm going to go through the concepts here very quickly, and then we go through the Excel. We're going to open the Excel file and basically find the parameters that we are going to talk about. In this course, we're going to be mainly interested in three parameters: mean, population average. So that's the first one. The second one is population standard deviation. And the third one is population proportion. For example, proportion of female students in our class, proportion of people that their height is above 6 feet, for example, and proportion of women golfers, for example, in the United States, stuff like that. So these are the parameters. These are the three parameters that we are going to talk about a lot in this chapter, right? So how do we take a sample from a finite population? Again, there are several ways that we can do that. But the best way would be taking a simple random sample. A simple random sample is when every member of the population, every member of the sampled population, right? Every member in the frame has equal chance to be selected, has equal chance to be a part of our sample. Or in other words, a simple random sample of size n from a finite population of size capital N is a sample selected such that each possible sample of size n, lowercase n, has the same probability of being selected. This is equivalent to saying every candidate, every member in the frame has the same chance of being selected. So this is the best way of taking a sample. Again, there are multiple ways for taking samples. This one is the best. And remember, whenever we have the most random your sample is, the most representative of your population your sample is, right? So that's our objective. We want to try to increase the randomness of our sample, right? So moving on, we're gonna go back to we're gonna just go into the Excel and try to take a sample. But maybe very briefly here, when we have infinite population, we do not have the perfect list, but what we can do is making sure that these two conditions are satisfied. First one, we need to make sure that each element is coming from the same population. The best way usually is to find is, I mean, it's hard for this one when we have infinite population. You can't really find a frame. You can't really find a perfect sampled population. But what we need to do, we just need to make sure that these people, the elements that are coming to be, that are going to be one of the members of your sample, they're coming from the same population, and also they're selected independently. There is no relationship between picking the first one and the second one and the third one. So you shouldn't be able to guess who's going to be in your sample before seeing the actual person being selected. All right. So this is another concept. Moving on. I'm just going to, again, move on to the point estimate. Point estimate, we are talking about 3 parameters, as I said. Sample mean, population mean, mu. Just move on. We're going to be talking about population mean, population proportion, and population standard deviation. For population mean, the best estimate, the point estimate is simply a point coming from your sample, just a value coming from your sample as an estimate for your, as an unbiased estimator for your population parameter. X bar, sample mean, is the best point estimate for population mean, is the unbiased estimator for the population. Sample standard deviation, S, lowercase s, is the best estimator or is the unbiased estimator for population standard deviation, or sigma. Sample proportion, P bar, is the unbiased estimator for P, lowercase p, population proportion. I'm now going to go ahead and go to the Excel file. But again, so we have these 3, X bar, S, and P bar, as the point estimate, unbiased estimator for mu, sigma, and lowercase p for proportion. All right, so here we have the list. Just gonna move on. This is the summary of what we will see from our Excel file. And now I'm gonna go ahead and go to the Excel file here. All right. This is the data file EAI. We have the list of 2,500 managers in a company. We are assuming that this is our population. This is our population, right? And so we have the full list of all the people, all the employees, all the managers that are working in a certain company. So that's the population. Population includes 2,500 employees. So that's the population of. Okay, so what I'm gonna do, I'm gonna find the population parameters, the ones that we are interested in knowing them, and then we're gonna create a random sample, simple random sample, and find the point estimate for them. So now population parameters. Some parameters that we are, we may, I mean, in this case, we're interested in, we're interested to know. Yes. So annual salary, I want to know the population mean of annual salary. I want to know population standard deviation of annual salary. I'm not writing annual salary, but this is the only quantitative factor here. So when we're talking about mean, when we're talking a standard deviation, we are talking about, we need a quantitative variable, a numerical variable, and the only one here, A is just a label, column A, column B, these numbers are the annual salaries of these people, the members of the population. So this is what we were talking about. And now we, in the list, in the data file that we have, we know whether these employees took a training program, whether or not they completed a training program, yes or no, the answer to that question. So I need to know, as one of the population parameter, I need to know the proportion of people, proportion of the employees who completed the training program, who did the training program. So for that, for the proportion, I need two numbers here. I need to know the count of people who took the program, who have yes here. And I also need to know the total count. And when I divide the count of people who said yes to the training program by the total number, which is 2,500, I will get the population proportion. So I just need to first count the number of yeses here and then divide it by 2,500. But for that, I'm just gonna say basically response of interest. I'm just recording yes as my response of interest, and then count of interest, total like size of population, or capital N, size of population, and then population proportion of people who took the training program. All right, so I may population mean or mu. Here I just write mu, standard population standard deviation, or sigma, and then population proportion, or P. All right, so these are the list of population parameters that we're interested to know. Just showing the formula. All right, the population mean, in order to get the mean, we can simply use the average function, average of the numbers. And I just need to put, I can select the whole column B. It's gonna exclude, it's gonna drop the non-numerical values. It's gonna drop, let's say, the annual summary text, and it's gonna find the average of the other values. So this is what I can do, but I'm just gonna only pick the numerical values. So B2 and all the way to the end of the table. Control Shift down. Right, so 51,800. That's the dollar. That's the average salary of these people. So I'm just removing the decimal. So that's the average. Standard deviation is stdev.p.population. All right, stdev.p of, again, the annual salaries, Control Shift down. So that will give me the population standard deviation, the sigma. Response of interest is yes. I just type yes. I just typed yes. That's what I want to count. So count of interest, count if. In column C, just count the number of yes. So 1,500 yes, 1,500 out of 20. So size of population, count. So here we have, in this course, we're gonna use these two functions a lot, count and count A. Count the number of, you see the number of cells that contain numbers, whereas count A counts the non-empty cell. So here, I just want to, size of population doesn't really, if you want to count the number of, if you want to use column C, you can't use count function. You have to use count A function. And that's what I want to do. I already know it's 2,500, but just in case, just to see how we can count the number of non-empty cells. And then population proportion. Okay, all right. Out of 2,500 people, 1,500 people took the training program. So 15 divided by 25, 60%. That's my population proportion, 0.6. That's the population proportion of employees who took the training program. All right. Now, that's for population parameters. Luckily, here we had the full list of employees, so we were able to find the population parameters, right? But most of the times we do not know the full list of the people. We don't have the frame here, if we just call it that way. We don't have the full list of, we don't know exactly who's who can be the member of the population, who actually is the member of the population. Because of that, we're going to take a sample. Now, this is how we're going to take a simple random sample when we have the frame, when we have the frame like this. So we're going to take random. We want to take. I'm just going to create a sample of size 30, right? So here we had 2,500. I'm going to take a relatively small, very small compared to the population size. It's going to be 30. So since I'm going to take them randomly, I'm going to have to pick them randomly. What I'm going to do, I'm going to assign a random number to each one of these managers. So random number. I'm going to assign so this is the process that we're going to follow here. We're going to assign random numbers to all of these people, and then we're going to sort the random numbers and take the top 30. That way we get a random sample here. So that's the idea. That's what we wanted. In Excel, there are two random functions. You have, if you type rand, you'll see both of them. Rand function, it returns a value between 0 and 1 using, it says evenly distributing, using the uniform distribution. Or rand between, and that is a basically discrete uniform distribution, and it only includes the integer number. So that has a very, compared to rand function, it's a very limited random function. Most of the time, we use rand function. That's a more general random function, and it gives you decimal numbers between 0 and 1 that are evenly or uniformly distributed. So this is what I'm going to do, rand function. And rand function, as you can see here, does not need any input. So you can just close the parenthesis and press enter. So that creates a random number between 0 and 1. Okay, all right. We have one random number. we're going to need to create 2,500 of those. So I can just double click on this, or I can just drag it down or double click here, and it's going to create 2,500 random numbers for me. All right. So now I have my random number. The problem with random number is that it just, whenever you do something, whenever you, for example, do whatever you do here, if you just start typing and then press enter, all these values changed. This is because random function is an active function. It's an active function. They're actually generating random numbers all the time, so they don't stop. Because of that, we are going to fix the numbers first, and then work with the fixed numbers, right? So what I'm going to do, I'm going to copy. So I have formulas all over the place, like the whole column includes rand formulas. What I'm going to do, I'm going to copy column D, copy the whole column, Control C, and paste it. But paste only the values. Right click on column D, paste special. Paste special, paste values, 1, 2, 3. That way, you see there is no formula anymore. These are random numbers. And if you just do anything, these numbers are fixed from now on. They don't change. All right. So now what I'm going to do, nothing has changed in my list. And now I have random numbers assigned to each manager. If I just filter the table, and if you sort this table based on these random numbers, it's going to give us a random sorting. And that way, if we take the top 30 after we sort, after we have a random sorting, that would be a random sample, a simple random sample of size 30 from this population. That's what I want to do now. If I click here and sort, let's say smallest to largest or largest to smallest, and then pick the top 30. I'm just going to include the labels and go all the way to, I just need to include 30 people, 30 employees. Control C, copy, and I just create a new sheet, call it sample, and paste it here. Just add a little space here. And all right. Okay. So now we have a simple random sample of size 30. And what I'm going to do, so here we have in my data tab, I have the population parameters. Now I'm going to create sample statistics, right? Sample statistics, they are random numbers depending on the sample, depending on who happened to be in my sample. The point estimates that I'm going to take are going to be different. Like if you do exactly the same thing as I did, you're going to get different numbers, different members in your sample. And because of that, you are going to get a different, so I just write sample of size or sample of, or random sample of 30 employees or 30 managers. All right, and now instead of population parameters, sample statistics. And these are unbiased or unbiased point estimates. Unbiased point estimate. Sample statistic. All right, so let me just, so now I need to find the sample mean, sample standard deviation. So sample mean is going to be not mu, it's going to be x bar, sample standard deviation, or S, lowercase s, response of interest, yes, count of interest 24, size of sample, and then sample proportion, or P bar. All right, so now sample mean average of B2 to B31, sample standard deviation stdev dot S, now B2 to B31, response of interest is yes, count of interest is 24, it happened to be 24 for me, count of the sample is 30, so 24 out of 30, 0.8, that would be my sample proportion. So now we have, so what we did, I quickly recap, we have, we had the population list here, 2,500 people, 2,500 managers. So we found population mean, population standard deviation, and population proportion of managers who have taken the training program, right? So these three population proportion, and so 1, 2, 3 population proportion, and then we took a random sample by assigning random numbers and sorting them and picking the top 30, and then for this sample of 30 managers, we found the unbiased estimators for the population parameters. Sample mean for population mean. Sample standard deviation for population standard deviation. Sample proportion for population proportion.